Welcome to the series I'm going to call Sciencing, intended to help you to better understand scientific research. This, the first module, introduces you to some common quantitative methods of research. Quantitative just means that this type of research focuses on things we can count or otherwise measure. This is the kind of research that informs everything from clinical practice, what kind of treatment you get, to public health advice and policy, hopefully using good, solid research. It's also the type of research that I have the most experience doing and reviewing or reading to basically put to use or to inform my own research. When referring to quantitative studies, it's common to talk about study design as opposed to study methodology, but really those terms you come across used interchangeably. The two broad types of quantitative studies in health research, and research more broadly too, are observational and experimental. Observational studies do as the name suggests. They involve observing but not intervening. They're designed to see what is there. A likely example that you may be familiar with if you're from New Zealand or even many other countries is a census. Experimental studies, on the other hand, have intervention at their heart. They're done to test interventions, to see if they work, basically. This is a very basic way of putting the question. Really, in research, we want to be much more specific than does it work? As in, does it have a specific effect? And sometimes we might want to know how it works. Again, we would need experimental research to work that out. Interventions can be in the form of medication or supplements, surgery, diet, counseling techniques, exercise, manual therapies, health promotion initiatives, really, you name it. Anything we might do to change health or behavior in some way. The key thing is that these are done as part of the study. It's common to compare one intervention to another, but not all experimental designs work this way. The experiment, or the intervention as I'm calling it, might be tested in people. It might be tested in animal models. It might be tested in cell cultures or similar, or even using computer simulations. Observational studies, going back to those, are useful for identifying possible associations between two or more things. For example, is there an association between smoking and lung cancer? They can therefore help to form a hypothesis. Experimental studies are useful for identifying the causal nature or not of specific associations. So does A cause B or B cause A? They can test if smoking causes lung cancer, and they can therefore test hypotheses to see how accurate they are. As a general rule of thumb, the research process moves from observation to experimentation, and from simulation through to in vitro and animal research to humans. Although sometimes one or more of those is skipped, depending on what's relevant, what's already known in an area, how safe an intervention is deemed to be, if we're talking about experimental work. But in general, this is the process things should go through before they make it to human research. Now, if you find this useful, please hit the like and subscribe. And importantly, more importantly, in fact, is keep learning by watching other modules in this series. And you can see some of those here and here, I believe.